Hi everyone, myself S. Saranya, Assistant Professor, Department of Mathematics, Bharadar Arts and Science College for Women, Deviya Kurichi. In this video, we discuss about queuing theory. First, we see that what is queuing theory. Queuing theory is the mathematical study of waiting lines or queues. In queuing theory, a model is constructed so that queue length and waiting times can be predicted. Queuing theory is generally considered a branch of operation research because the results are often used when making business decisions about the resources needed to provide a service. Examples of real world queuing system. Commercial queuing system. Commercial organizations serving external customers. For example, dentist, bank, ATM, gas station, garage. Transportation service system. Vehicles are customers or servers. For example, vehicles waiting at a toll station under traffic lights. Trucks are ships waiting to be loaded. Taxi cabs, fire engines, buses, etc. Business internal service system. Customers receiving service are internal to the organization providing the service. For example, inspection stations, computer support, etc. Social service system. For example, hospital, waiting list for organ transplants. Problems of a customer. Why does it always feel to us like all other queues move faster? Which queue should I take? Where shall I append? How long do I have to wait? Where there are the fewest people in queue, where the people have the least products to dispatch, where the fastest cashier is, where one can only pay cash, where someone helps me backing. Queuing theory for studying networks. View network as collection of queues. First in, first out data structure. Queuing theory provides probabilistic analysis of these queues. For example, average length, average waiting time, probability queue is at a certain length, probability a packet will be lost. Queuing model queuing system. In this picture, explain the queuing system. First, the customer enter the queue and waiting the queue and service and then leaving the queue. Use queuing models to describe the behavior of queuing system, evaluate system performance. Assumption. Independent arrivals, exponential distribution. Customers do not leave or change queues. Large queues do not discourage customers. Many assumptions are not always true, but the queuing theory gives good results anyway. Measuring the queue performance. There are a number of measures that can help a manager to balance the capacity and waiting cost. Average time in a queue, average length of a queue, average customer time in the system, number of customers in a queue, probability of numbers in a queue, probability of system being unused. The last two above, looking at a probability, is where most of the work on queue theory goes on. Components of a basic queuing process. There are calling population, arrival process, queue configuration, queue discipline, service process. Principal queue parameters. First one, calling population, arrival process, service process, number of servers, queue discipline. The calling population. Population of customers or jobs. The size can be finite or infinite. The latter is most common. Can be homogeneous, only one type of customers or jobs, or heterogeneous, several different kinds of customers or jobs. Arrival process. In what pattern do jobs or customers arrive to the queuing system? Distribution of arrival times, batch arrivals, finite population, finite queue length. Poisson arrival process often assumed. Many real-world arrival processes can be modeled using a Poisson process. Service process. How long does it take to service a job or customer? Distribution of arrival times, rework or repair, service center breakdown. Exponential service times often achieved. Works well for maintenance or unscheduled service situation. Number of servers. How many servers are available? Single server queue, multiple server queue. Example, 2 queue configuration. Multiple queues, single queues. Multiple versus single customer queue configuration. Multiple line advantage. The service provided can be differentiated. For example, supermarket express lanes, labor specialization possible. Customer has more flexibility. Bulking behavior may be deterred. Several medium length lines are less intimidating than one very long line. Single line advantage guarantees fairness. First in first out applied to all arrivals. No customers anticipate recording choice of queue. Avoids cutting in problem. The most efficient setup for minimizing time in the queue. Jogging is avoided. Queue discipline. How are jobs or customers selected from the queue for service? First come first served. Shortest processing time. Earliest due date. Priority. First come first served default assumption for most models. 3 queuing disciplines used in telephone networks. First one, first in first out. This principle states that customers are served one at a time and that the customers that has been waiting the longest is served first. Second one, last in first out. This principle also serves customers one at a time. However, the customer with the shortest waiting time will be served first. Last one, processor sharing. Customers are served equally. Network capacity is shared between customers and they all effectively experience the same delay. This is example for first in first out. This is the example for last in first out. SIRO, service in random order. That is like drawing tickets out of a pool of tickets for service. Single server, single queue stage. Multiple server, single stage queue. Single server, multiple stage queue. Multiple server, multiple stage queue. Types of queues of interest. Analytical models for estimating capacity and related metrics. Single server. It is denoted by m/m/1, m/g/1, m/d/1, g/g/1. Multiple server m/m/c, m/g/infinity, etc. Multiple stage Markov chain models. Infinite source queuing models. Single channel exponential service time. Single channel constant service time. Multiple channel exponential service time. Multiple priority service exponential service time. Business applications. It is a practical operations management technique that is commonly used to determine staffing, scheduling, and calculating inventory levels to improve customer satisfaction. Six Sigma professionals, through their knowledge of probability distributions, process mapping, and basic process improvement technique, can help organizations design and implement robust queuing models to create this competitive advantage. Time illness. Businesses conduct studies using mathematical models and formulas to determine the best way of serving the greatest number of customers given their staffing resources. In retail businesses, the volume of transaction is extremely important in maximizing revenues and profitability. Remove inefficiencies. For example, bank needs to stick to its model once it's been determined that maximum efficiency can be achieved both in labor cost and customer served by using a generalized queue based on staffing at least 3 tellers during peak hours. Imitation of queuing theory. The assumption of classical queuing theory may be too restrictive to be able to model real world situation exactly. The complexity of production lines with the product specific characteristics cannot be handled with those models. Often, although the bounds to exit, they can be safely ignored because the differences between the real world and theory is not statistically significant, as the probability that such